Hello students, welcome to aimsindia online classes. This is a chemistry session. Here we are going to discuss about the chapter language of chemistry. In this session we are going to see the introduction and some basic concepts from this chapter language of chemistry. Chemistry is a branch of science which deals with the study of chemical substances, their composition and their properties. Yes, in chemistry we study about the chemical composition of different matter and the different substances and their composition with which they are made up of and their properties. What are the different properties of those chemical substances we study in the branch of science which is called chemistry. To make it easy and a systematic study of the subject, chemistry subject is divided into various branches. Yes, in chemistry again, there are different branches to make it easy and convenient studying of different components, different chemical substances. They made this chemistry into different branches. We can see here the different branches of chemistry. Yes, like organic chemistry, inorganic chemistry, physical chemistry, analytical chemistry, industrial chemistry, nuclear chemistry, biochemistry, and nanochemistry. These all are the different various branches of chemistry. In each and every, we discuss about different corners of this science, about chemical compositions and properties of these chemical substances we study in these. Okay, these are different various branches of chemistry. Chemistry and its language. Yes, it will be very interesting to hear. Chemistry is having its own language. Yes, when we learn a new language, we start by learning alphabet, isn't it? Suppose if you start learning English, where do we start that? We start learning first the alphabets ABCDs, and then we write words, isn't it? First we learn writing of the learn these alphabets, whatever the language it is. If we learn first time we learn alphabets, by using those alphabets we start writing words, and finally these words form sentences. In this way we learn a language. Whenever you learn a new language, first alphabets, by using these alphabets we learn words writing, and finally these words frame, we use the different words to frame sentences. In this way we learn any language. In the same way, while learning chemistry also, we start by learning symbols of the elements. Yes, first we learn symbols and then formulae of the compounds, and finally we write equations of reactions. Yes, while learning chemistry also, first we learn symbols of different elements present. By using these symbols, we start writing formula of different chemical compounds. By using this formula and symbol, we write chemical equations for the chemical reactions. In this way, we learn chemistry. So, as it is, chemistry is also having its own language with the symbols, formulae, and equations. How a language is having words like alphabets and words and sentences, how we learn. In the same way, in chemistry also, first we learn symbols. By using these symbols, we write words. By using these words and symbols, we start writing chemical equations for the reactions occurring. Okay, what is this symbol first of all? We use many symbols in mathematics to avoid writing full and lengthy terms so as to save our time and to make it convenient, isn't it? For example, if you say instead of writing addition, just we write a symbol plus. Instead of telling subtraction, just we write a minus symbol. Instead of telling division, just we write a division symbol. So these are all the different symbols which we use in mathematics to avoid writing fully and lengthy terms. To make it easy and convenient, we use symbols in mathematics. Similarly, a stenographer uses shorthand to save time in taking down notes. But symbols of stenographer are totally different from symbols we use in mathematics. So in different ways we use different symbols. So just these all are to make it simple, to make it easy. We use symbols in different ways. The need of symbols also felt by chemists as science advanced. Yes, chemists also they felt using these symbols instead of writing complete names for these chemical substances. They started using these symbols. In chemistry, a symbol is defined as the shorthand sign or the shorthand notation of the full name of an element. The shorthand notation of the name of an element is defined as symbol. Simply to say, the simple representation of an element name. J.J. Berzelius suggested a method of representing elements using English capital letters. Yes, he was a scientist who suggested these namings of the elements, giving symbols for the elements. He is a scientist who suggested this method of giving symbols to the elements, which we are using nowadays. Each element has a unique symbol assigned to it. Yes, each and every element is having its own symbol. The symbol of an element is not used for any other element. Yes, the symbols are unique. No two elements are having same symbol. We know, as we came to know till now, 118 elements. Came to know around 118 elements till now. These all, each of these elements have their own symbol. No two elements are having same symbol. For example, if you see the symbol or shorthand form representation of the element hydrogen is H. In chemical changes, when we write H, it means the element hydrogen. So instead of writing complete name hydrogen in chemical reactions and words, in writing the formula, just we write H. This H represents the element hydrogen. The symbol or short form representation of the element oxygen is O. In chemical changes, when we write O, it means the element is oxygen. Yes, the element oxygen is given the symbol O. Here, in chemical reactions or formulae, when you write O, that represents the element oxygen. Okay, next. Some elements are having their symbols from their Latin names. For example, element sodium has its symbol as Na because the Latin name of sodium is natrium. Generally, as per Berzelius suggestions, the symbols are taken from the starting letter of the element. The first letter of an element's name is taken as a symbol for the element. If this first letter is already existing as symbol for some other element, then along with the first letter, second prominent letter also taken into the symbol. For example, if you say hydrogen, the first letter of hydrogen name is H. So its symbol is taken as H. But if you see helium, helium also having the first letter as H. But H is already taken as symbol for hydrogen. Then along with the H, second prominent letter E also taken into symbol for helium. So it became He as symbol for helium. And for some elements, the symbols are derived from their Latin names. For example, if you see sodium, its Latin name is natrium. So in this, the starting letter is N, but this N is already it is a symbol for some other element nitrogen. So along with the first letter N, second prominent letter A also taken into the symbol. Now the symbol of sodium becomes Na. So it is taken from its Latin name natrium. Okay. So we have to know this point here. Actually, we are telling these symbols were suggested by Berzelius, and by giving some rules and regulations to write the symbol, he has given these symbols. But before this Berzelius method, so different scientists they have proposed many systems to represent the elements. For example, Dalton, one of them, Dalton proposed some symbols for the elements by using circles and plus or say minus or dots symbols inside the circle. These all suggestions were given by Dalton. But It became difficult to remember those symbols as number of elements are increased. At the starting, as there were few elements, they have remembered those. But as number of elements being increased, the remembrance of those symbols became difficult. So now we are following this easy and convenient method proposed by Berzelius. But before that, there were some. Next, atomicity of the elements. Atomicity. The number of atoms present in one molecule of an element is called its atomicity. That means the number of atoms present in one molecule of an element is called its atomicity. Based on the atomicity, the elements can be classified into different types. Means based upon the number of atoms present in one molecule, atomicity is given for that element. So based upon the atomicity, elements are classified into different types. Let us see one by one those. First one is monoatomic elements. It means the elements with only one atom in their molecules are called monoatomic elements. So the elements which are having only one atom in their molecule are called monoatomic elements. Here we know what does mean mono. Mono means single. Monoatomic means single atomic elements. The elements which are having only one atom in their molecule are called monoatomic molecules or monoatomic elements. For example, noble gases like neon and metals like copper, silver, etc. These all are having monoatomic elements. These all are monoatomic elements. They contain single atoms in their molecule. Okay. Next, diatomic elements. The elements with the two atoms in their molecules are called diatomic elements. We know what does it mean by di. Di represents here two. So the elements which are having two atoms in their molecules are called as diatomic elements. For example, you see hydrogen, oxygen, chlorine. These all are elements which are having two atoms in their molecules each. See here, hydrogen molecule has two atoms in its molecule. Element oxygen is also having two atoms in its molecules, even chlorine also. So in this way, the elements which are having two atoms in their molecules are considered as diatomic elements. One more classification, triatomic elements. So we can say the elements with the three atoms in their molecules are called triatomic elements. We know here what does it mean tri. Tri represents three. So the elements in which there are three atoms in each molecule are considered as triatomic elements. Example it is shown here O3. What it is called? Ozone. Ozone, it is an element which is having three atoms in each molecule. Okay, it is called triatomic element. Next, polyatomic elements. Generally, the elements with the two or more than two atoms in their molecules are called tri or polyatomic elements. Poly represents many. So the elements which are having more than two atoms in their molecules are considered as polyatomic elements. Example, phosphorus, sulfur. These all are polyatomic. For example, if you see phosphorus, it has four atoms in each molecule. So it is one of the polyatomic element. If we see next one, sulfur, it is having 8 atoms in its molecule. So it is also polyatomic. To say exact number, phosphorus is considered as a tetraatomic element. Tetra represents 4 atoms. In each molecule of phosphorus, there are 4 atoms. So it comes under tetraatomic element. What about sulfur? If you observe here, there are 8 atoms in the molecule of sulfur. So we can say sulfur is a octaatomic element. So these all come under polyatomic elements which are having more than two atoms in their molecules. Okay. Next, valency. During the formation of molecules of compounds, atoms combine in certain fixed proportions. This is because of the fact that atoms have different combining capacities. Yes, one atom can combine to two atoms. Some atoms they can combine with only one atom. Some they can combine with many atoms. That depends upon the combining capacity is different for different elements. Based upon the combining capacity of an element, the number of atoms combining with that will be varied. Okay, this combining capacity of an element is called its valency. The combining capacity of an element called its valency. Actually, the valency is measured in terms of hydrogen atoms or oxygen atoms. The valency of hydrogen is taken as 1 and it is selected as the standard of valencies. Yes, generally the valency of hydrogen is taken as 1 and this valency of hydrogen is taken standard and the valencies of remaining elements are calculated or assumed. How it is, let us see. Thus, the valency of an element can also be defined as the number of hydrogen atoms which combine with an atom of it. So the number of hydrogen atoms combining with one atom of an element is taken as its valency. For example, if you say in methane molecule, in methane, one atom of carbon combining with four atoms of hydrogen. So the valency of carbon is 4. In this way, based upon the number of hydrogen atoms combining with one atom of an element is considered as its valency. For example, in the methane molecule, each carbon atom is combining with four hydrogen atoms. So the number 4 is considered as the valency of carbon. See here, in methane molecule, each carbon is combined with four hydrogens. So 4 is taken as its valency of carbon. Okay. Next, since all atoms do not combine with the hydrogen, so the valency of the element is also defined in terms of elements like oxygen and chlorine. So here we have seen how the valency of carbon is determined because here carbon is combining with hydrogen to form compounds. But all the elements they may not combine with the hydrogen. That is why the valency of elements is also defined in terms of other elements other than hydrogen like oxygen and chlorine also. If you see in terms of oxygen, the valency in terms of oxygen, the valency of oxygen is 2 as oxygen valency is 2, double the number of oxygen atoms with which one atom of an element can combine is called its valency. Okay, as the valency of oxygen is 2, so it is taken as a standard and based upon the number of atoms combining with oxygen, its valency is defined. How it is, how the oxygen valency is 2, if you see in water, one atom of oxygen is combining with the two atoms of hydrogen. So by taking the valency of hydrogen as 2, it is considered the valency of oxygen 2. Now, by taking its oxygen valency 2, the valency of other atoms is determined or defined. In which way? Here it is given. Double the number of oxygen atoms with which one atom of an element can combine is called its valency. Let us understand this by taking one example. In calcium oxide, one atom of calcium combines with one atom of oxygen. So the valency of calcium is 2. What we said here? Double the number of oxygen atoms with which one atom of an element combining. If you take one atom of calcium, in calcium oxide, one atom of calcium is combining with one atom of oxygen. So double the number of oxygen atoms combining here with one atom is taken as valency. So with one atom of calcium, one oxygen atom is combined. So number of oxygen atoms into 2 gives the valency of the element with which it is combined here. Okay, in this way, the valency of calcium is found to be 2 because each calcium atom is combined with one atom of oxygen. The number of oxygen atoms into 2 gives its valency. Okay, in this way, the valencies of the elements are defined based upon the number of oxygen atoms combining with it. See here, in calcium oxide, one atom of calcium combining with one atom of oxygen. So the number of oxygen atoms combining into two gives its valency. So its valency became 2 now. In the same way, the valency is also defined in terms of chlorine also. Valency also can be defined as the number of chlorine atoms with which one atom of an element can combine, because the valency of chlorine is also 1. If you say in HCl molecule, hydrogen chloride molecule, one chlorine atom is combining with one hydrogen atom. As valency of hydrogen is 1, valency of chlorine also becomes 1 now. So as valency of chlorine is being 1, the valencies of the other elements also can be found based upon the number of atoms combining with one chlorine atom. So how it is? The valency also can be defined as the number of chlorine atoms with which one atom of an element can combine. Okay. For example, we will say in sodium chloride, one atom of sodium combines with one atom of chlorine, so the valency of sodium is considered as 1. See here, chlorine valency is considered as 1. Now, the number of chlorine atoms combining with one atom of another element is considered as a valency of that element. Now here, one with one chlorine atom, one sodium atom is combined. So one sodium atom is combining with one chlorine atom. So the valency of sodium is considered as 1. Okay. Now, some general assumptions are there in finding the valencies of the unknown elements by using the valencies of the known elements. So what are the assumptions? Let us consider here. Let us see those. First one is the valency of hydrogen and all metals is considered positive. Generally, the valencies of the metals and hydrogen are considered as positive valencies, and the valencies of all non-metals are generally considered as negative. Of course, even hydrogen is also one of the non-metal, but its valency is generally considered as positive along with the metals. Valencies of remaining non-metals are considered as negative. And as the molecule of a compound is electrically neutral, it is assumed that total positive valency in its molecule is equal to total negative valency. Yes, generally the molecules of the compounds are neutral. From this we can say the total positive valencies in a molecule is equal to the total negative valence in that molecule. They will nullify each other. Positive valence will be equal to negative valency. Okay. Next concept, variable valency. Variable means changing. An element with more than one valency is called variable valency or variable valent element. The existence of more than one valency is called variable valency. And that element which can exhibit more than one valency is called variable valent element. Okay. It has been found that certain metals exhibit more than one valency. In such a situation, metals are said to be exhibiting variable valency, and those elements which are exhibiting more than one valency are called as variable valent elements. For example, if you see iron, iron can exhibit two valencies. What are those two? Fe plus 2 and Fe plus 3. Iron can exhibit two valencies. In different compounds, different valencies are seen for iron. In some compounds, we observe iron with plus 2 valency, and in some compounds, it is observed with valency 3. So, in this way, not only iron, some more metals and non-metals they exhibit more than one valency. That phenomenon is called variable valency, and those elements which are exhibiting more than one valency are called variable valent elements. Now, how to name an element with two different valencies? Suppose if you see sodium, it has only one valency, it is called sodium ion. If I say now iron ion, it might be Fe plus 2 or Fe plus 3 because it is showing two valencies. So how to name specifically Fe plus 2 ion? How to name specifically Fe plus 3 ion? How to name a particular ion of variable valent element that we are going to see now. If an element exhibits two different valencies, then suffix us is attached at the end of the name of metal for lower valency. Yes, if it is exhibiting two valencies, then for the lower valent ion, us is attached at its name ending, and suffix ik, ik is attached at the end of the name of metal for higher valency. We can see here, as I told, iron can exhibit two valencies, plus 2 and plus 3. Then Fe plus 2, because here Fe plus 2 is the lower valent ion. Actually, the name of iron in Latin is ferrum. So for the name ferrum at the end, us is attached by eliminating 2, 3, 1 or 2 letters. So actual name of iron is ferrum, Ferrum. It is a Latin name of iron. From this, last two letters are omitted and us is attached to this fer. Now it becomes ferrum or ferrous. Fe plus 2 ion is called now ferrous ion. One more ion exhibited by iron is plus 3 ion. As it is a higher valent ion, for this IC is attached. Now actual name is ferrum. From these last two letters are omitted, and for this fer, is attached, so it becomes ferric. So Fe plus 2 is a ferrous ion, Fe plus 3 is a ferric ion. So in this way, the lower valent ion is named by attaching OUS at the end of its name, and the higher valent ion is named by attaching IC at the end of its name. In this way, the variable valent elements are named in the different valencies. Okay. Thank you for watching our video. Please subscribe our YouTube channel Aims Today for latest updates and recorded videos. Thank you.